Okay, this is number 28 from the 8th grade and under Sycamore Math Invitational. And there are two really good ways to solve this problem. And the first way is to recognize that in a function, if our function is f of x squared plus ax squared, or f of x equals ax squared plus bx plus c, then we can find the sum of the coefficients simply by evaluating the function when x equals 1. And the reason this works is 1 squared is 1, so that gives you a, b times 1 is b, and then c, a plus b plus c is exactly what we're trying to find. So we're going to utilize this fact, evaluate the function at f of 1, to get our answer here, because we want to find the sum of coefficients. So, for our problem, we want to find out the sum of the coefficients of f of x minus 2. Well, when x is 1, that means we're trying to evaluate this function when x is 1, which is f of negative 1. So we need to calculate the value for f of negative 1. Well, we know what the function is, or at least the function when you have x plus 3 as the input. So to get f of negative 1, all we need to do is plug in a negative 4 for x into that function at the top. So plug in negative 4 for x. That gives you f of negative 1. You get negative 4 squared plus 9 times negative 4 plus 10. That gives you 16 minus 36 plus 10, which is negative 10. And negative 10 is the correct answer on this problem. That is a pretty advanced way to approach that problem, and it's only efficient at finding the sum of the coefficients. If you actually want to know what the function is, then there's another approach to this problem that I want you to know, and that is to recognize that my function is f of x equals ax squared plus bx plus c. And I know what that function looks like when evaluated at x plus 3. So I'm going to look at that. So that's going to give me a times x plus 3 squared plus b times x plus 3 plus c. I'll go ahead and do this multiplication for us just quickly. You can evaluate it on your own or check it on your own later. X plus 3 squared is just x squared plus 6 plus 9, 6x plus 9. And then you get plus bx plus 3b plus c. And the reason this is good is that whenever you're comparing two polynomials, i.e. this polynomial and this polynomial up here, for them to be the same, then their coefficients of each of the terms has to be the same. I only have one x squared term here, and the x squared term at the top, it has a coefficient of 1, so that tells me that a equals 1. If I know a equals 1, then I can simplify x squared, a equals 1 here, so that's plus 6x plus 9, plus bx plus 3b plus c. If I now look at the x term comes from adding 6x and bx, but I need the x term to be a coefficient of 9, so that means b must equal 3, because 6 plus 3 equals 9. So I simplify again, and that's going to give me x squared plus 9x plus 9, plus plugging 3 in for b there gives me 9, and then plus c. And then to find c, I recognize that the constant term must be 10, and so this here must add up to 10. So 9 plus 9 is 18, so you get 18 plus c equals 10. So c must equal negative 8. That means my function is f of x equals, a was 1, so x squared, b was 3, so 3x, and then the constant term is negative 8, so you get x squared plus 3x minus 8. So now we actually know the function, and then finding the sum of the coefficients of this is simply a matter of plugging in x minus 2. That gives you x squared minus 4x plus 4 plus 3x minus 6 minus 8. That gives you x squared minus x minus 10. Coefficients here are 1 and negative 1. Those cancel out. That means the sum of the coefficients of f of x minus 2 is negative 10. So either way is a nice way to do it. This way is really efficient, works really well when you get to really complicated polynomials if you're trying to find the sum of the coefficients. But knowing this method is also important because sometimes you actually need to know what the function is to do something else with it.